So now we're going to power through this part 3, artist. So we have talked about pie plot, figures, axes, and then now we're at the bottom of the barrel here, although no less important, the artist. Anything that can be rendered is an artist of some form or another, or a combination of artists. That's what an artist is. It can be a line, it can be text, it can be a polygon, a marker. Anything that can be rendered is an artist. Matter of fact, oddly enough, even an axis object is an artist, but we have these artists, and this is the basic underbelly of all Matplotlib, is that it is all the way down. You know, just like turtles is artists all the way down to the bottom. So let's show you some artist objects that are available. Supposed to run that. Okay, these are just some of them. We have wedge, arrow, line 2D, rectangle, ellipse, fancy box patch, circle, polygon, and polypatch. There is a difference between polygons and polypatch. Sometimes you want a patch. Patches are really good for repeating. So if you have many of something, you want it to be a patch, because then we can make certain assumptions and certain optimizations, so that way we don't have to waste a lot of memory storing the location of every single one of the patches or something like that. Meanwhile, if you just have a single polygon or something like that, just use a polygon. And there's some other subtle differences, but this is just a subset of them. But you combine all these things. These are all primitives, and you combine all these things, and you make your plot. So when I call plot.bar, and remember back in that first part where I showed you how to make a plot in 3 lines of code. There is so much stuff Matplotlib is doing under the hood for you. When you call plot or bar or hist or something like that, it computes everything you need to compute, and then it creates for you all these different artists automatically. And so it says that, the bar function will go, oh, I'm going to need a polygon that is going to be so wide and so tall, and it's going to have these colors and these properties, and so you call the bar function, and it's going to do that for you. This is how you can make your own custom plotting functions, is that you can go ahead and use these artists and compute what these artists are going to be, add them to the axes, and away you go. That's how you can extend Matplotlib to do a lot more interesting things if you wanted to. Or you can add on and decorate your plots any way you want by adding additional artists to your plot to somehow enhance and add more information to your plot. So all these artists, remember we were talking about various properties in the previous section. You can set these properties for all these artists. That's the basis for all these things. So showing you an example here, we're going to do a plot. I'm going to receive that list of line 2D objects. And here, in this example, I have 2 line plots that are done. And I'm going to change. I'm going to change the line width on the first one. And I'm going to change the line width on the second one, but I'm also going to make it have an alpha to it, so it can be slightly transparent. We're going to run that, and there you go. that was a way for me to modify the properties of this plot. Because remember, I'm doing two plots in a single plot command. I can't say, line width equals a list 5, 3, and then to have the alpha be a list of 0, 0.7 or something. I can't. It doesn't work that way. This is a way how you can set different properties for your artists. And so you can see what sort of properties are available for your artist through this command, this getP thing. You can find out what the properties are. So this is a full listing of various properties. You can set edge color or EC. You can set the cap style. B box is bounding box. Don't worry too much about that. Alpha, join style, what the label might be, the line style, whether or not you have a picker, that's for interactive use, things like that, whether it's visible, all sorts of things that can be modified through here. And it's all different based on whether or not you're, which type of artist you're dealing with. They all have different artist property values that can be modified, but some properties are the same across different artists. So that's a single artist. You can have a collection of artist objects that are all of the same type of artist. It makes it a little bit easier to manage. So, for example, there is a line collection that is basically a list of 2D line 2D objects, and you want to modify the properties of them. You don't want to be going through a for loop and looping through each and every single one of them and changing that property. You just have a collection and it will do it for you. So here, an example, I just created a line collection, which is just a list of vertices. So I have a list of vertices. So this will create 3 lines. The first one only has 2 points. The second one has 3 points. The third one has 3 points. And then for the line collection, I'm going to set the color. I'm going to set the line width. And then I'm going to add that collection to the axes object. So this is now, we're getting down into the deep underbelly of Matplotlib. You now actually have to manually say that this artist is going to go into this axes object rather than it being done for you automatically. And then you have to explicitly set the limits because there's no auto scaling at this point because you didn't actually do a plotting function. So we're going to see what happens. There you go. We have 3 lines. They're all red, and they all have the same line width. And that's how you can and so I didn't have to loop over anything. It just took care of it for me. So it helped manage a lot of artist objects when you want to treat them all the same. Now, it does not preclude the ability to individually modify anything. So in this case, I can I can say to set the line width and say I want the first one to be line width of 4, the second one line width of 3, and the third one to be a line width of 6. I can do that. And I can say that the first one is going to be red, the second one is going to be blue, the third one is going to be this RGB tuple. Again, I didn't have to loop over anything. So it made it easier to manage this way. Again, this is stuff that you're not going to be dealing with most of the time. But this is giving you all the rope that you need when you want it. So there's also there are other kinds of collections that are not simply just a list of primitives, but they are artists of their own type. You know, kind of like a single artist. They take advantage of various optimizations, as I talked about earlier. And whether you realize it or not, you actually are using these when you do plots, and sometimes when you do scatter, because it can make sort of assumptions at the high level. And so here's an example. I'm going to make a pentagon, and they're going to be large pentagons, and that trans offset you see here, that has something to do with the transformation of the so which transform am I going to use for the offset? These are the sort of things that get taken care of for you automatically when you're doing plots and stuff underneath. So, I'm saying that I want the values are going to be offset here, 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 and I mean them to be in data coordinates. So that's what they all mean. I could have said trans-axes, mean axes coordinates or something like that. And so now, this is going to create 20 random pentagons. There you go. And so it's a single collection, and I can modify the properties of these collections all on its own. In these sort of situations, these collections, you have to have them all like the same color. Because some of these collections assume that in order to make it easier to do various optimizations. So, as an exercise, I want you guys to give yourself some gold stars. So you can load up this example exercise and you can modify it. Once you make it gold, once you give yourself 4 of them, and the stars, they have 5 points. So that's why it says star polygon collection. The first argument at 5 is that it's a 5-pointed star. You can make it 6-pointed, you can make it 3-pointed, whatever. You can do that. And note that this particular example, as it stands right now, will only produce 1 star because it only has a single offset value. And note that it still has not said which color it's going to be. And because we don't have a lot of time, I'm going to move on here. Did I? Oops. Okay, looks like I forgot to update that. I have apparently overwritten my solution to this one. I will have it up on GitHub later today. So because we're short on time, I'm going to skip this one. You can look it up on GitHub later. There's like one other funky thing that I'm trying to remember, and I can't remember off the top of my head right now. So we'll move on. All right. We'll now move on to the very last section, Part 4, MPL Toolkits. This is more of just a showcase thing than anything else. So we're basically wrapping up at this point. MPL Toolkits. These are tools that are a part of Matplotlib but are not kept in Matplotlib's namespace for various reasons. For example, basemap is a mapping tool to help plot maps, various things, makes it really, really easy. But because basemap packages with it all of this shapefile data, all that for the whole world, packages can be, depending on the resolution you select, can be up to a few hundred megs. So we do not ship basemap with Matplotlib, in the same namespace. We make it a separate package available. Meanwhile, other packages such as mplot3d, which is a 3D plotting tool, it's not a part of Matplotlib proper because it's not quite right, but it gets the job done most of the time. And so we didn't want to include it as part of Matplotlib because we want to have the freedom to be able to change things a little bit more, but yet we do ship it with Matplotlib by default. Then there's Axis GridOne, which is another very useful tool for doing things. However, it actually breaks some things in Matplotlib when you use it. A few corner cases, but it actually, because of the way it's designed, it's actually different enough that it's not right for us to include it as part of Matplotlib proper, but we make it available for you guys to use when you want to. So quickly going through, and then there are a few other toolkits, but those are the three that are part of that are part of the regular development cycle for Matplotlib. Also, basemap gets its own development release cycle because it gets managed separately. mplot3d, by taking advantage of what I was talking about earlier with the Z orders, we can trick. We can emulate sort of a 3D-like effect through the layering. However, it is not perfect. And so kind of show you an example, show you a wireframe. And you can rotate it, you can interact around, you can do things like that. You can zoom. No, I'm left-clicking and dragging to rotate this frame around. I am right-clicking and dragging to do the zooming feature. And so you can get this sort of effect, and that's perfectly fine for many people. Issues come up when you want more complicated scenes, where you want, let's say, some sort of polygon to cut right through that. It won't display properly because you can't actually compute you can't actually compute that without an actual 3D rendering engine. So, but something simple, that will work. If you want something more complicated, then you have to switch over to something like Mayabi, Viz5D, or some other toolkits. There's another one called Glumpy that's being worked on. We're hoping that eventually that will mature to the point where we can actually integrate that into Matplotlib itself, and the Matplotlib will have a true 3D renderer. So, but that's not in store for us right now. Axis GridOne. I like Axis GridOne for a variety of things. It's fun. It has a lot of really useful features. Makes it really easy. For example, I can create a set of axes objects, but note that it automatically took away the labels in between the axes because I wanted them all to be the same. These are all shared, so as I pan around, the axes labels all move for me. And I have a color bar that spans 2 rows. And the space was allocated for it separately. All I had to do was say, I have these 4 and I want 1 color bar over here. It's great, it's wonderful for that. Then I'm going to show the parasite. This is, I don't know how else to describe this. This is kind of like Twin X I was showing you guys earlier, but taken 1 step further. That I have 3 things supplied. Remember, we don't have triplet X or something like that. We only have twin X because you only have a right and a left. But what if you need 1 more? Parasite axes is that. You can add a parasite axis that parasites on top, to another axis, and so it adds that other scale out here that you want. So another spine, if you will. And then this is another really neat thing that Axes GridOne can do. If you ever wanted to do that, you can. If you want a rotated axes for some reason, or you want to do this sort of wedge arc thing, you can do that. Yeah, and there's a few other features that you can do with Axes 3D Axes GridOne that are useful as well. So if you and there are examples of what you can do with Axes GridOne in the gallery. So if you go into Axes GridOne section, you can see some of the things that you can do with that. So it's really neat, really powerful tool. But because it breaks some assumptions with Matplotlib, you had to keep it outside of Matplotlib proper. Yes? The question was, and this kind of goes back to the first section, we're kind of wrapping up now. What is a suggested backend to use? Matplotlib was developed to be agnostic to any of the backends. You pick the backend that works best for you. There's no real, different backends are good for different reasons. So for example, if you're on a Mac, Cocoa Ag may be the better choice, but especially since Apple decided to break a while ago TK, so you really can't use Tinker very well on Macs. But yeah, you can go ahead and use Cocoa. But then again, Cocoa Ag has some issues with animation, so there gives and takes there. We support absolutely fully TK, GTK, and QT. Matter of fact, version 1.4 that will be released soon will have support for Qt5. So we support all those fully. We also support WEX. We actually almost got rid of it, and then somebody piped up and said, WEX is still alive. They're getting a release, and they did, and so we ended up supporting that. We also support Cairo. Well, it's a combination of Cairo and GTK. We support that. With Windows, we don't do Windows native. We do, what you do is you'll use either TK or GTK or Qt as built for Windows. Now, what will happen is when you build and install Matplotlib, if you're building from source, it's going to try to figure out what is available to build against for you automatically and choose one for you. But you can override that anytime you want. So I really can't say that there is a preference because they're all basically supposed to be the same. You can then, because there are all these different backends, you can actually then embed your figures, your stuff in a larger app that you're developing in Qt or in GTK or in Tinker or something like that, you can embed that figure stuff all in there, because that's essentially what you're doing already. When that figure window comes up, that is a mini embedded app that, that we fire off and embed the figure in. So you can embed that in any of your other apps if you want. So and that's backends. Any other questions? I mean, this is basically it. So anybody have any other questions? So you guys will be, I expect to now start seeing publications using Matplotlib. I can tell when you're using a Matplotlib figure in a publication. So we are going to do a release candidate this week. So, and then, so it'll go through the beta process, you know, basically for the next couple weeks. And so we're hoping sometime midsummer it'll be released. Well, we just need to make sure that everything, skewed transforms. We now have a 3D quiver. We have, Phil, what other, Phil gone or, yeah, it'll be in the release notes of what's new. So all very exciting stuff. All right. Thank you.